Alright, so this is part 4 of the automated manufacturing series, or option topic for information process and technology. 6.4 is about other information processes. So we're looking at the types of production in manufacturing. So first of all, we have to understand that there are some processes that occur in the automated manufacturing system. And that is what's defined as the manipulation of data. So we're looking at the manipulation of data in terms of data coming in, so the raw type of data that comes into a manufacturing plant and then becomes information, and then what is it that comes out on the other side, and how that happens. So of course data must be converted into a form for transmission, and the way that's done is it's basically mass production and the different types of production. So we're going to be looking at the different types of productions: mass production, discrete, continuous, batch systems. They're the sort of things that we're going to look at, and we're going to define them in this video. So the first thing we look at is of course mass production. Now, I have already sent some links through to you on different types of mass production. You looked at the mass production of the Tata Nano and how it is produced, and there's some definitions behind that. So the definition of mass production is it is the manufacture of products in large quantities. And why do we do that? Well, if we can produce something in large quantities, then what happens is you save time and cost. Not only do you save time, but also you save the cost of the product that's being produced. So it's a reduction. And quite often I give the example of talking about mass production and savings in terms of large warehouses having lots and lots of different products, and they can buy lots and lots of products at a reduced rate and sell them at a reduced rate to the consumer. It's based on 4 principles. Number 1 is the specialist tasks that are relatively simple. If you're looking at a car body, I know I keep referring back to cars, but if you're looking at a car body, you're welding in certain spots, and the production is very, very simple. Number 2 is the standardization of parts. Allows them to be readily fitted. So there's a mass production of the parts that have to go into the production process. Also, specialist machines, materials and processes minimise the amount of human effort. So we understand that a labour force is quite slow compared to a robot that does repetitive tasks. We're going to get into robots and how they work shortly, but they allow for repetitive tasks to happen. Number 4 is the planning of the whole production process. I spelled process wrong. Permits the best balance between human effort and machining. So there are people out there that are employed to actually define or design these production plants, and they not so much as reduce human, but also redefine what human effort there is. So if you're ever answering a question on in the HSC about the social and ethical issues of mass production, you would have to define that one of the social ethical issues is, a lot of people say, people lose their jobs because of machinery and less humans are going to do those repetitive tasks. Well, it's actually not that case. It's actually that the human actually is become retrained, or what we say re-skilled in an area. So they don't effectively lose their job. They just tend to be re-skilled in an area. Now I've got a couple of videos here. This one's on the production of how rubber bands are made. I do have this listed, and I will have it listed below in this YouTube video on that I'm creating on how rubber is made. So I'm not going to play this video, but rubber, you can imagine, would be mass produced because of the rubber bands are mass produced because they're constantly being made. The next one is, of course, Lego, and you can go and watch this video as well after I've given you a bit of an explanation. Of course, Lego is made from plastic, and plastic can be mass produced, and then you'll see in this video that there is not a lot of human interaction or human production. It's mainly robots and conveyor belts, and the whole process is less and less humans because, and you can imagine how many Lego bricks are actually produced in mass production. So the next one, of course, is the different types of production. And the first one you can see there is a continuous system. And a continuous system is something that, lo and behold, it is continuous. And it can produce, it operates 24 hours a day, of course. So less and less human interaction, and of course it can be used in chemical manufacture, food production, and basic metals. And as you can see, in particular chemical manufacture, the key issue here is safety. So the social and ethical issues of mass production of a chemical or continuous system is that you can produce chemicals that less human interaction because of the safety aspect. Things like your common garden fertilizer could be produced in a continuous system, and it would be very safe because there's not as much human interaction with the mixing of the chemicals. Same with food production, things like lollies, biscuits. They're a continuous system where simply the human or a system starts with the ingredients being placed into, say, a kettle or a hopper or something like that, and then whatever comes out the other side. So things like ovens are a continuous system where the product goes into the oven and then comes out the other side cooked. And then of course we have things like basic metals as well. So the steel industry, for example, is a continuous system. They operate 24 hours a day, and the human interaction is with the start of the production plant and also the end of the production plant. Usually what's produced is a gas, a liquid, or a powder, and I have a little video here which shows you the continuous production line for a liquid. This one is demonstrating, and most of these videos are advertisements online for an explanation of how, I think it is a medicine that is produced, and it's a continuous line production. So you can go ahead and watch that video. You can pause this one. It will be linked in the description below, so you can get it from there. The next type of production is a batch system. Now, a batch system is where it can be a mass production system, but it also has batches. Now, when you watch the documentary about Lamborghinis, the Lamborghini video is a batch system because some of the Lamborghinis are custom made to the owner's specifications. Then I've got an example here on this video which is of creating popcorn, and the batch system decides what it's going to create as far as popcorn goes. So it has the opportunity to create caramelized popcorn, and that would be a batch of popcorn created. There's a number of ways that you can create a batch system, and you quite often hear things like there was a batch of this type of car made, or there was a batch of this type of chemical made, and in the production plant. So go ahead and watch this video. You can pause this, but I'm going to move on. The next one is a discrete system. Now, a discrete system is where something I like to say, it says here in a discrete system, it performs one single task. And so a discrete system would be, something like a piece of furniture that is handcrafted but not mass produced by, like IKEA or, fantastic furniture would be mass produced furniture, but let's say something that's made out of wood that's handcrafted by a manufacturer or a person is performing one single task. I have a video here that demonstrates the performance of one single task by a young boy who shows you how to actually make a wooden bowl. And you can see that it would be very discrete and one-off, and there's all different types of videos. I have seen a video where it is mass-produced wooden bowls, and the techniques are quite amazing. And if I find it, I might actually post the link in the description for that as well. But go ahead and watch the team woodworker make a wooden bowl. It's a one-off, and you can see why this would be a discrete system. Then we have the next part of this is about actuators. Now, actuators are motors, and motors, the official term for motors is an actuator, and we're going to learn about all the different types of actuators or all different types of motors, how they work and what they do. And specifically, what they do and why is really important in this subject, because once you understand the concept of how the motor works, then you need to know the applications of the motor. I have found that some students who are studying this subject also are studying physics, and they do study motors in physics, and they learn how they work. So what is an actuator? Well, an actuator actually performs the actual work of the system. So it is in things like conveyor belts, it's in like robotic arms, and we'll get into the importance of a robotic arm and conveyor belts and the difference between the two types of motors shortly. So we have 4 types: electric motors, stepper motors, relays, and hydraulic pumps are the types of actuators that are talked about or mentioned in the syllabus. So, and also there's 5 of them. Solenoids is the other one. So then the first one is a solenoid. Now, a solenoid looks like, in your textbook, it looks like this. And this is a solenoid which, the basic movement of a solenoid is that once electricity is put through this coil, this moves backwards and forwards. And a solenoid is used in a car engine to actually help start the car. So cars are, So solenoids are used, had a bit of a malfunction there, but solenoids are used in cars to actually assist in the starting of the car. Now, a car needs the motor to be spinning in order for it to start. So when you turn the key of a car, the solenoid is engaged and a little electric motor spins the engine to actually get it started. And I've got a little video here which is from a science guy that explains how solenoids work. And what he's saying here is that you can see that there is a coil of wire here, and it creates an electromagnetic field, and this is magnetized to this, and it moves across there. So you can go ahead now and watch that video. Then, of course, we have a video on how a car starts, and this is a very old video showing a guy cranking the engine to get it started, and we don't have to do that anymore because we have solenoids and starter motors. The next part of this is relays, and relays are, I've got a description here, a video here of what a relay is and how they work. So you can go ahead and watch that and perhaps take some notes from your textbook. So we have, I went too far. Relays are also a part of the textbook and also part of the syllabus as well, so you can go ahead and take some notes on that, and I will move on. Then we have electric motors, and electric motors were explained in 6.2 that we have electric motors to spin, and so this is an electric motor. Inside it is, of course, some magnets, and the electricity goes inside a coil, and it produces an electromagnetic field. The magnets are sort of opposed to what's going on and create a spin. The more power you have, the bigger the magnets, the bigger the motor you have, so on and so forth. Now, what are they used for? Well, you know, they're mainly used for the movement of things like wheels or conveyor belts. So that's what a DC or a direct current motor, how it actually works. And there's a video on that, so you can see that one. Now, the next one is a stepper motor. Now, I think a stepper motor is the most important motor that you need to know about, and I'm going to explain it in terms of why. Let's get the bell's gone. Robotic arm. Right. So if I get an image of a robotic arm up on the screen, here's a perfect one. So yep, I like, did it around the wrong way. Let's just choose that there. Open link in a new tab. Righto, oh, it's a tiny one. Anyway, I'll move on. So here is a robotic arm, and you can see that it's a gripper arm, so it grabs hold of things. So obviously these have the opportunity, whether it's hydraulically, so the use of liquids, or whether it's mechanically, the use of motors to actually squeeze that together. But also you'll notice that there is a number of joints on the robot, including down here, which I would say in here would be a stepper motor. These could be stepper motors in here, but they might possibly be hydraulic. But a stepper motor is really important in a robotic arm, and I'll explain why. You'll watch a video in here, so I'll just move this forward. Right, so here is a video about, I do that all the time. Right. Keep going, DC, and I just want to pause this. All right, so you'll watch a video about how a stepper motor works in regards to a robotic arm, but I'm going to explain it in terms of what the HSC says. All right, so here it is. Now, if this was a motor, you can imagine that if this robot picked up something and then placed it over here, then if this was a motor, it would spin off the area where it was supposed to pick it up, and then pick it up, if it did pick it up, and then spin, but it wouldn't be able to brake and stop and drop it to where it was supposed to be. Now, what a stepper motor does is it has very, very accurate movements based on where the location of the magnets are inside that. So go ahead and watch this, and it explains it perfectly how a stepper motor works. Then, of course, we have hydraulic pumps, and I've got a video here which talks or explains all the different types of hydraulic pumps. Hydraulics means liquid, and pumps, obviously, it's going to pump liquid some way. Now, one important thing that you need to know about hydraulics is the reason that we use it is because liquid is very hard to compress. And when you know that concept, you can use it in a number of ways, whether it's putting it in from a reservoir into a system and pumping something out, or using it to ensure that nothing gets compressed. And so it can hold a lot of force in many, many ways. So that's why hydraulic pumps are important in automated manufacturing systems. Then, of course, we have the digital to analog conversion. So we've got to understand that, and here's the diagram of this. So we have binary, of course, which is the digital, and we have that decimal, and then the analog is the volts. So these are the types of conversions that we have for an electric motor. So when we have, say, a value of 1 on an electric motor, it equals 0.04 of a volt. Now this could be anything. This could be the rotations of a motor or the revolutions of a motor. So one revolution produces 0.04 of a volt. And once we know that, we can then use those motors to actually produce electricity. And in simplest terms, the rotation of a motor is how a coal-fired power station works. So you might say, well, hang on a minute. How does a coal-fired power station result in the revolution of a motor into 0.4 of a volt? So what they have is, instead of it being called a motor, it's the reverse effect of electricity going into a motor spins. Then a generator is the spinning of a motor to produce electricity. So it's the reverse of that. It's like talking into a microphone. If you reverse speaking into a microphone, it's sound. So microphones can work as speakers. But this is the other way around for the production of electricity. And the way it works is that coal-fired power stations, we burn coal to boil water to produce steam, which turns a turbine blade under pressure, which is attached to a motor, which is actually not a motor, it's actually called a generator, and it produces electricity. So that's how the digital to analog conversion happens in that regard. Now, of course, this means that we have transmitting and receiving, and the most effective one is, of course, a signal, which is translated into signal conditioning, which means this word, noise. So we have to do things with noise. We have to fix noise because it's dangerous and it can create long-term effects for workers. And we're going to, next in 6.5, we talk about social and ethical issues of automated manufacturing systems, where we talk about safety and ensuring a worker's safety. But one of the things that is important is ensuring that they are protected from noise. And how do you do that? Well, you do a couple of things. You put shielding around machinery that is making a lot of noise, and you also use things like filters. So a filter can be just simply rubber. So if you put rubber flooring down, it will dampen the noise that's made. I shouldn't use the word damp, because damping is actually a different definition, and we talked about that in 6.3. It's more a case of filtering out the noise or blocking the noise so that it's not dangerous for humans. Of course, one of the other filters that we use is earmuffs to block out noise so that we don't have any long-term effects. So what's going to happen now, I'm going to produce there will be a homework task allocated to you on our OneNote, and so I would like you to stop taking your notes here after you have taken enough, watched all the videos, and then complete the homework.